In this video, we're going to talk about potable water and how you get it and where you get it from. Now, potable water is just drinking water that has sufficiently low levels of salts and microbes, and we filter out all of the material that's bad for you out of that water, and then we kill most of the microbes. So there's a good low level of both, which is perfectly safe for you to drink, and that's why we call potable water water that is safe to drink. Now, potable water is not pure water because it has other substances dissolved within it, stuff that we add as a country. For example, we add fluoride to our drinking water, and that fluoride is meant to help with strengthening of your teeth, for example. And then we also have dissolved ions in it from where we got it from. But let's talk about those dissolved ions first. So, water coming out of the tap, and then you can see, where does that water come from? Well, it comes from here. So imagine it's raining, okay? It rains into the hills and the valleys, and it collects on the mountains, and then goes in the streams, and then collects together in lakes and such and so forth. Now, we call these lakes that we choose to get our water from reservoirs, okay? So there are reservoirs everywhere across the UK. Now, those reservoirs, we then take the water out of it, and that's the point at which we start to treat it. Now, because it goes through the mountains, okay, and through the rivers, it collects ions as it goes along. So if you look here, these are the two major ions we want you to think about, which is calcium and magnesium. And calcium ions are also good for teeth, okay? So we think that it's good to have those calcium and magnesium ions in there because it's generally good for your health. Now, they're naturally in there because of running over the rocks and slightly dissolving the rocks, but the fluoride is an additive that is added to help you with your dental hygiene. Now, there are three possible sources of potable water, and one is wastewater. That is waste from industry and things like that, and from houses, homes, which can include anything from effluent from the industry or sewage, and it can include also defecants like poo, pee, dead animals, anything really. Okay, and that requires lots of different stages of treatment, and therefore each stage of treatment will require lots of energy. Groundwater is the best source because groundwater can even be found pure. So sometimes it's found as mineral water, okay, and sometimes it can be potable from the start. But most of the time it has to be filtered, and it has fewer stages than wastewater, but it still has to be treated. Okay, and that is where most of the water is got from when it comes to Europe and the UK. Now, salt water. Salt water is by far the most costly because it has lots of stages and lots of energy. Desalination, which we'll talk about briefly later, includes distillation, and it involves reverse osmosis. Now, in terms of that, it's a lot of heat energy you need to distill tons and tons and tons and tons and tons of water. Okay, so it's very, very costly. So let's look at the UK, and let's look at how potable water is produced here and in many other countries in Europe. Now, you choose an appropriate source, a river or a lake, and let's just see our graphic here again. Might be good to go over your water cycle in geography. And you can see that precipitation here, raining down onto the mountains, collects in the streams collect together into the rivers, that then goes into a lake. Where we collect the water is a lake that we term a reservoir. Sometimes they're man-made, most of the time they are natural, okay? And we just say that they are reservoirs, and that's where we're going to collect our water from to be treated. Now, once we've got our source, we then have to filter. So filtering-wise is done through sedimentation, and again, everything that's really important for the exam is highlighted. So sedimentation is important, and the solids then start to fall to the ground. Now, what kind of solids are they? So the kind of solids we have sticks, okay, and we can have stones, but we can have lots of other things. These are just two examples. Now, those sticks and stones, okay, if we make them small, and we take the filter, and we put it down there, we've put a filter, you can just about see it if I put my finger along here, there's a filter across the top. Now, that's a coarse filter, lots of big holes in, so that'll stop the sticks. Stones will go through though, and then those stones fall to the bottom. And we can see it here. Okay, so that's the sticks are being stopped, and then what happens is we then start to drain out. We drain out through this sand bed, and it's a filtration that goes through the sand bed. As you can see, the water coming out there. Now that filtration through the sand bed, okay, is a fine filtration, so it gets rid of any tiny, tiny particles, and as you can see the stones here, but it'll get rid of anything really, okay? Now, or anything that's large anyway. But what it won't get rid of is the microbes. So you have to get rid of microbes by killing them, and I say killing them very clearly because that's again your mark-worthy point. Now, if you're going to kill these, you need to do it through 3 ways. And again, it's gone all green because this is your exam answer. We've got to choose a source. We've got to sediment out those particles, let them fall to the ground, and then we filter it through a coarse filter like we have at the top, and then fine filter in terms of the sand. Then we sterilise, kill the microbes using chlorine, that's a classic one, okay, but we can also use ozone, and we can also use UV light. Okay, so they pass over UV light and that kills them as well. So this is the exam answer for you to say how potable water is produced in the UK, and which will be asked in your exam. Our final example of making potable water is through desalination. And this is done in hot countries which don't have a lot of rainfall, for example, Saudi Arabia and Spain. So first of all, they have to choose an appropriate source of seawater, and then they have to distill or do reverse osmosis. Now, distillation involves a huge amount of energy and heat, okay, which means it's very costly in terms of fossil fuels or electricity. Reverse osmosis is different, still will take a huge amount of energy, okay, but all you need to know for this is that it uses it. So it uses reverse osmosis, okay, to get your potable water through desalination. You don't need to know any more details, but you do need to know about distillation. And you know about that through your required practical 8 that you would have done in class, which is analysis and purification of a water sample. So for example, you have a water sample that has some ions dissolved in it or something dissolved in it. And you do it through this process. So what you've got here is your setup for required practical 8. It's just a test tube with some water in, and then you heat it with a Bunsen burner very gently, okay, and then the water boils and then goes over here, and when you press that, when you heat that for a long length of time, it will travel over and over and over, and this will go down and this will go up. So if you carry on like that, and you carry on until this is totally evaporated, as it says down here, you'll just have calcium and magnesium ions left over in here, because remember, potable water is not chemically pure. So there'll be calcium and magnesium ions down there. This should be pure water. Now, quick question, because this is in the exams as well. What safety apparatus would you need for this experiment? Well, the only safety apparatus you need, because it's water, and water is not bad for you, okay, is the fact they wouldn't want any hot water to get in your eyes or anything like that, okay, because this could blow off, for example, if the pressure built up. And so they're going to want you to wear safety goggles, okay. So every time we talk about required practical, we'll talk about the safety as well, because that's a simple 1-mark question. Now, you've got your calcium and magnesium in here, and you've got your pure water here. But how do I tell that it's pure water? That's a really important question they often ask. So let's take the pure water that we've got here, okay, and look at how we can do it. Well, there's 2 ways. One way is looking at the pH, and this is a pH meter. And you've got the exam answer here. Take the pH of the pH meter. If the pH is 7, you have pure water. That's one way of doing it. Okay, and you will have done that in your required practical 8, just assessing the purity of water through the pH. You can also do it through the boiling point. This is quite easy to do as well. So alternatively, boil the water, and you do it using a thermometer as well. So you can monitor the temperature using the thermometer and take the boiling temperature. So get it to boil, just get a beaker, get it to boil, get your beaker of this water, boil it, and once it's boiling, just stick the thermometer in. If it is roughly equaling 100, because usually there's a range, okay, but remember, it's about 2 degrees normally in a boiling or a melting temperature, okay, so if it equals 100 degrees, then you have pure water, but your exam answer basically is equals 100 degrees, you have pure water. So there's 2 ways of finding out whether your water is actually pure. pH, it's well worth emphasising this, pH, or boil the water and make sure that that boiling point equals 100 degrees Celsius.